Why, hello there, lovely one. So we're busy going through questions that are related to geometry, and we're looking specifically at the IEB Paper 2, November 2016. This was question 10. So before we read all of the information, it's important we look at what's happening in the picture. We can see that we're told that there are two lines that are parallel on this side and lines that are parallel on that side, which means we're looking at proportionality. Now that we have a kind of an idea of where we're going, let's read it. The diagram below is the top view of a design of a new railway system. There are 8 stations being built, and these are labeled with the letters from A to H. So A, B, C, yes, we can do that. As the engineer, you know that AF is parallel to BE, yes, and AC, there's AC, is parallel to GD. Then you'll also know that AB over BC is 7 over 4, and AG over AF is 9 over 17. Now, before I get wrapped up in all of these questions, I'm going to put this information on the diagram. Let's start with these over here. So if I have AB is 4 and BC is 7, those over there, it doesn't necessarily mean that AB is going to be 4 meters or 4 kilometers or 4 any of those. It just means that the ratio between them is 4:7. So I'm going to change it to 4x and 7x. And of course, then I know if those are there, then this whole thing is going to be 11x. Okay, let's do the same with the next part. We've got AG is 9, so AG, let's put the 9 there, and AF, oh, that's the big one, is going to be 17. We can't say it's the same ratio as these, so I'm going to use Y, or the same unit. Yeah, I'm going to use Y, and if that's, this should be 8Y over here. Okay, so I've put my information on the diagram. Let's look at the first question. It says calculate FE over FC. That shouldn't be too bad. We know that FE is in proportion. Oh, let's do that. I'm going to do it in red. We know that FE is going to be in proportion to FC in the same way that it is on the other side, so it's also going to be 4 over 11. Well, not also, but you see, I'm sure you understand where I'm going. Okay, then the next one, and then you would write down that it's proportionality, blah blah blah. The next one says calculate CD over DF. So let's take a look. We've got CD, and that's in relation to AG, and DF is in relation to GF, so I'm going to just say that it's 9 over 8. Once again, why is it? It's proportionality theorem. Now here's where the question becomes more exciting. It says if the straight line distance from track F to C is 374 kilometers and it takes 50 hours to build 1 kilometer of track, determine the number of hours it will take to build a section from E to D. So we already know that we've got some proportions happening here. We know that this one is going to be 8 is to 9. And we know that this other one is going to be, let's line it up, it's going to be 7 is to 4. But it's not the same units as what's above. So I'm going to allocate new units to it. I'm going to call this 4K and 7K. And then at the bottom, let's call it 8P and 9P. And the reason why that's useful, and now my drawing is getting all sorts of weird, is because we're told that that distance is equals to 374 kilometers. So I know that 4k plus 7k is going to equal 374 kilometers. I also know that 374 kilometers is equals to 8p plus 9p. Okay, so I've got 374 is equals to 11k, which means that k is equals to 34 kilometers. We're going to do the same thing with the other side. 374 is equals to 17p, which gives us an answer of p is equals to 22 kilometers. So the reason that's helpful is now I know that I need to calculate the distance over here, e to d, and I can do that because I know what all of these values are going to be. It is looking a little untidy, so I'm just going to redraw it over here to make it more obvious what I'm doing. F, E, then we've got D, and then we've got C over here. And I said that this over here was going to be 4k, so that's 4 times 34 kilometers. So there we go. And then on the other side, I had this equals to 9p, so that's going to be 9 times 22 kilometers, and that means I can work out this section over here. So we know that in total it's 374 kilometers. I've got 4 times 34 plus ED, and I'm going to scroll over to the side now, plus DC, whoopsie, plus DC, which was 9 times 22, and this will allow me to calculate ED. And doing some fancy mathematics, I calculated that ED was 40 kilometers. Now what's going to happen for most people is at this stage they're going to think they're done with the problem, and that's why it's important to read the question again. It says if the straight line distance of the track from F to C is 374 kilometers and it takes 50 hours to build 1 kilometer of track, determine the number of hours it will take to build the section from E to D. So I still need to convert that to hours in terms of how long it took. If it takes 50 hours to make 1 kilometer and we've got 40 of them to do, it means it'll take 2,000 hours in total. And at this point it is a good idea to write a final sentence to show that you know what you calculated, and it would say something like it would take 2,000 hours to make the section from E to D. Now there is one more thing I want to point out, and that is this is not the only way to do this question. It's just the way that I like to do. It made me feel comfortable, and that's exactly why I did it that way. Maths is all about feelings, and if you feel good, more than likely you're going to do better. With that, it's enough from me. Much love.